All right, so we're going to do partial area and compound shapes. So we're going to smush shapes together and make them part of shapes. Now, here's the thing with this. If I do the partial area of a rectangle, it'll still be a rectangle. So it won't change. Like the math won't change for it. The only thing that really changes is circles. So let me show you what I mean. So here's an example. So for all circles, for an arc or for a segment, I would need the fraction of the circle that segment is times the full circle's area. So when I have this, and I want only this section of it, only this section of it, I need to figure out how much of the circle this is. There's one of two ways that this can happen. One way is that they'll actually show you the fraction of the circle it is. So in this instance, this might be a fifth of a circle, right? So it would actually show you this. You don't have to eyeball it or guess or anything. But if this is 1/5 of the whole circle, we would do 1/5 times pi r squared, which is the area of the whole circle, right? So it could be done with fractions, or it could be done with degrees. Now, this is 160 degrees is what it says. I know I have tiny handwriting and I really wish I didn't. So if the whole circle has 360 degrees, we want to figure out what fraction of the circle this is. So this is the segment. This is called the arc length. So the other option, sorry, I already said this, is arc length, which is this section over the whole circle, which is always 360. So 1/5 would be whatever a fifth of 360 is. That would show you the same arc length. Now, I want to just warn you, arc length can show you down here, or it can show you like out here, but it's the same number both ways, because degrees is how much you've changed, not a distance. Y'all, I tried to make my writing clearer, and I just ended up making it smaller. This is 2 inches for the radius, and the circle 60 degrees here. Now, I want the area of the shaded region. So what I'm going to do is I'm going to take the 60 degrees out of the whole circle. I'm going to find that fraction. I don't really need to find it, but like it's there. And then I'm going to multiply that by pi times the radius squared. So 60 out of 360 is about a sixth. So I get 1/6 times 4 pi. Or how this actually usually looks is that we usually go like 4 pi over 6. This is usually enough. I hate doing this. I just made up numbers, so this is why it's kind of hard. 4 over 6 can be simplified to be 2 over 3. So this is the same thing as 2 pi over 3. So this section of the circle, square inches. See, I always forget this part. All right. So that's how I find the area of a part of a circle. I also am going to do one more where it already shows you the fraction. Actually, I'm not. This is also a very common one. This is a semicircle or a half of a circle. It's literally half of a circle. The other half would be down here. So for this one, I would do half of the full circle, which has radius of 7, because this is the diameter. So just as a reminder, when I do the diameter, if the diameter is 14, the radius is 7. Okay, so that's my diameter. So I'm going to do half of the circle, because this is literally half of the circle right here, times pi times 7 squared, which is going to be 49 pi divided by 2 square centimeters. If you didn't catch how I did that, I didn't want to actually divide 49 by 2, so I just wrote 49 over 2. I could do 49 divided by 2. This would be 24.5 pi. If you wanted to write it that way, it's fine. So that's a different way. Now, I did of the shaded region in parentheses because sometimes it won't shade it for you, and if it's that case, it's just the part you can see. But if it does shade it for you, it's looking for a specific section. All right. Compound shapes are more than one shape that have been put together. So this could be like an ice cream cone. That's a triangle with a semicircle on it. Or it could be a weird shaped rectangle, 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 rectangle. Okay, so let me show you one of those. I just should not have used this. Okay, so this is a compound shape. It's not a normal shape we can find, but it's made of normal shapes we can find. Now, there are 2 ways to think about this problem, and you probably already actually have a method of thinking about this. So option 1 is I can think of this as shapes being added onto each other. So how we visualize the same shape if it's being added on, hold on, let me redraw it, is you could think about this as like the top piece and the side piece, right? So you could find these both separately and add them together. Or you could also think about it if the line was like here, or you could think about it in 3 parts. It doesn't really matter. It really doesn't. So in this case, what I'm going to do is I know this is a 5 and this is 2. And then I can, because it doesn't tell me, I can assume that this is actually cut in half like it looks. So this would be 2 inches and this would be 2 inches. I can assume that. If it shows me other numbers over here, I probably can't assume that. So the top right here would be a 5 by 2, which is 10. And the bottom right here would be 2 times 2, which is 4. So together the whole shape is 14 square inches. Okay, that's one way to think about it. Let me show you another way to think about it. So, but these are being sums of shapes, right? I'm combining shapes together. So another way to think about the same problem is if I cut it this way, right? And actually, this might be easier to think about. So this would be 5 inches still. This was 4 inches. This was 2 inches. Now, if this was 5 inches up here, and this is 2 inches down here, then this is probably going to be 3 inches over here, right? Because this face and this face make the top face. So that would be 3 inches. So now I can do this box and this box. So this is not a 5 by 3. This would be a 3 by probably 2. We're not sure still, but we can assume. So this would be 3 times 2. Consistency, Miss Willard. And then this one would be a 2 by 4, which is 8. And so I can add up 8 plus 16, or sorry, 8 plus 6, which is 14. So again, I get the same answer. It doesn't matter how I think about it. Now, there is one other way to think about this as a subtraction of shapes. So the other way to think about this would be that I have a whole rectangle and I've removed a section of it down here. Okay. In both of these cases, I've added my 2 parts together. In this case, I'm actually going to subtract this section. So I take the whole shape, this whole thing, which is a 5 by 4. So the whole is 5 times 4, which is 20. And then the part we are going to be taking out, so the removed, I don't know how to say that a different way, was I think a 3 by 2. Doesn't look like a 3 by 2, but it is. So we're going to remove 3 by 2, which is 6. So I can subtract these two, and I get, lo and behold, 14 square inches. Do you have to, here's why I'm showing you 3 different ways. Sometimes it's a lot easier to do the subtraction than it is to figure out where the shape is put together. Okay, sometimes it's a lot easier to see the whole and subtract the part. But there's at least 3 different ways that I could just visualize right away seeing this problem. So something that's kind of cool about areas, compound shapes, is that you can do it a million different ways, or at least 3 different ways. So just be flexible and keep your mind open to all the different possibilities. There's so many ways to do this. All right, and if you saw a different way and you still got 14, we're good. Like, we're good. All right. Yeah, that's it. Have a great day.